Picture this. It's a perfect summer day. The sun is blazing, and you see this beautiful, warm freshwater lake that just looks so inviting. But hiding in that water, totally invisible, there could be a microscopic predator. Now, it's not looking for you, but if you happen to cross its path in just the wrong way, it could lead to one of the most terrifying infections known to science.
Okay, let's just get right into it. This right here, this isn't a prop from some horror movie. It's a very real sign you might see posted near a lake in Florida. It warns about something called Naegleria fowleri, an amoeba that enters the body through the nose and causes a rare but fatal brain infection. So what is this thing really, and how seriously should we take a warning like this?
So to really wrap our heads around this threat, we have to meet the culprit itself. Let's get to know Naegleria fowleri, what it is, and where it likes to hang out.
Naegleria fowleri is a tiny, single-celled organism, an amoeba, and it's a totally natural part of the ecosystem in warm, fresh water pretty much all over the globe. Now, the key thing to get is that it's a facultative parasite. That's just a fancy scientific way of saying it's perfectly happy living on its own, munching on bacteria in the sediment. It doesn't actually need a host to survive. We humans, we're just tragic accidental victims.
This amoeba is a bit of a shapeshifter. It has 3 different forms. On the left, you've got the cyst, which is like its tough, protective survival shell. On the right is the flagellate form, which uses a little tail to swim around and find a better spot. But it's this one in the middle, the trophozoite. That's the active, infectious stage. That's the one that causes all the damage.
So how on earth does this microscopic organism get from a peaceful lake into the most protected organ in the entire human body? Well, the route it takes is incredibly specific and terrifyingly direct.
This diagram from the CDC lays out the whole journey perfectly. It all kicks off with that trophozoite form hanging out in the water. Then, someone's swimming or diving, and a bunch of water gets forced up into their nose. That's it. That one moment is the point of invasion. And from there, the amoeba has a wide open path to its final destination.
And this is the absolute key. The amoeba latches onto the olfactory nerve. That's the nerve that handles our sense of smell. It essentially uses this nerve as a superhighway, completely bypassing the body's defenses and traveling straight from the nose into the frontal lobe of the brain.
Now, this is a really, really crucial point. How you can, and just as importantly, how you cannot get infected. The only way this happens is when contaminated water is forced deep into your nasal passages. Let me be crystal clear. You absolutely cannot get this from swallowing contaminated water. Your stomach acid will destroy it, no problem. It's also not contagious. You can't catch it from another person.
So once it's inside the brain, the amoeba unleashes a catastrophic and incredibly fast-moving disease. It's called primary amoebic meningoencephalitis, or PAME for short. This timeline really shows you just how brutally fast this attack is. After exposure, the first symptoms pop up, and they're tragically common. Things like a headache, fever, nausea. You'd probably just think you have the flu. But from there, it progresses with horrifying speed to confusion, seizures, and a coma. Usually, death occurs within just 1 week of the very first symptom.
And all of this leads to a truly staggering number. The fatality rate for PAM is over 97%. I mean, let that sink in. To put in perspective, between 1962 and 2022 in the United States, out of 157 people who got infected, only 4 survived. It is, almost always, a death sentence.
And this image, I know it's graphic, but it tragically shows you exactly why. This is a brain from a patient after they passed away. The amoeba doesn't just cause inflammation, it actively consumes brain tissue. It's literally eating the cells. This destruction leads to massive swelling, bleeding, and tissue death, what's called necrosis, which you can see all over, especially in the front parts of the brain.
So, with a disease this aggressive and this deadly, is there anything at all that doctors can do? Well, the fight to save a patient with PME is an unbelievable race against time, and the odds are just massively stacked against them.
As this quote says, the diagnosis really boils down to one thing: finding the amoeba in a sample of the patient's spinal fluid. And because the disease moves so unbelievably fast, a rapid diagnosis is crucial. Every single hour matters.
But finding it? Well, that's like looking for a needle in a haystack. This slide shows you exactly what pathologists are frantically searching for under a microscope. A single amoeba, right there where the arrow is, surrounded by the body's own white blood cells. Spotting that one tiny cell is the key to everything, all while the clock is ticking away.
And the challenges don't stop even if you get a diagnosis. There is no proven cure.
There's no vaccine, there's no standard treatment protocol. Doctors have to resort to experimental drug cocktails because the disease is so rare and moves so quickly, it's incredibly difficult to study what actually works. But there is a glimmer of hope. This table shows a few of the very rare, recent survivors, and you start to notice a pattern. This one drug, miltefosine, was used in all these cases. And in the cases with the best outcomes, the ones who survive without major brain damage, doctors also use something called therapeutic hypothermia. That's where they cool the body way down to protect the brain from swelling. It seems like that combination might be the key.
So, okay, we have this incredibly rare but devastating disease. You might be thinking it's not something you really have to worry about. But scientists are now looking at Naegleria fowleri, not just as a medical horror story, but as a potential canary in the coal mine for a much larger global problem.
The connection is frighteningly simple. This amoeba loves heat. It thrives in warm water. So, as our planet warms up, our lakes and our rivers are staying warmer for longer periods of the year. And that directly expands the amoeba's natural habitat, pushing it further and further north into places it's never been before.
And this isn't just a theory. The data is already showing that this is happening. Cases, while still very rare, are on the rise. The amoeba is being found in northern states like Minnesota, where it used to be unheard of. And, weirdly, some cases are popping up that aren't even linked to swimming, which is a whole other mystery we still need to figure out.
This all leaves us with a really critical question for the future. As our world keeps warming, will this rare killer become a more common threat? It's a chilling reminder that the consequences of a changing climate can be completely unexpected. It might not just mean more heat waves and bigger storms, but it could also mean waking up ancient microscopic threats that have been hiding in our waters all along.